The field of machine learning engineering has gotten very popular over the past few years. In the span of a decade, this field went from being very niche to being one of the most popular in-demand roles in all of tech. That said though, it isn't really well known what a machine learning engineer actually does. Hi, I'm Dan. I'm a machine learning engineer for a large tech company, and this is my channel, AI Stamp. I've been working as a machine learning engineer in big tech for the past 3 or so years, and also I've been in the tech industry for about over 6 years now, and I want to answer the question, what does a machine learning engineer actually do, especially at a big tech company? So let's start with some definitions. What is a machine learning engineer? Simply put, it's not really well defined, and the roles vary across company to company, particularly as startups, but I can define it simply as this. A machine learning engineer is a software engineer who uses machine learning techniques to move some kind of metric in a positive direction. More on that metric later. Before we can talk about what machine learning engineers do in big tech, let's actually talk about how big tech especially uses machine learning. And I'm going to come up with 3 unofficial buckets of ML work that goes on in big tech. Those buckets being classifiers, recommendation systems, and Gen AI. Again, this is unofficial. I'm just trying to keep things simple for explanatory purposes. Okay, so classifiers are your traditional ML models. Think a classifier that predicts whether this picture is a dog or a cat. Or your classic spam classifier. Is an email spam or is an email not spam? And this is the kind of work that an intro to machine learning class would teach. So classifiers are employed heavily within the industry. In big tech, it's often used in what's called content moderation systems. For example, is this video low quality or not? Does this video contain hyper inappropriate things or not? One classic examples of companies that even build their entire revenue model using classifiers would be medtech startups who would use X-ray data to help build systems that can assist radiologists in helping read X-rays. Next is what I would term recommendation/search systems. I'll start with search systems. This is like your classic Google search. Typically, a search system would work by a user enters a query, and then the system in the background would translate that query into a vector called an embedding, and then there would be a bunch of search results that are also embedded. And you would just have these algorithms that match the embeddings of the search results to the user query. The next type of application for machine learning is a recommendation system. Now, rec systems, or recommendation systems, give people what they want to see, for example. And applications of recommendation systems are really broad-reaching. It ranges from e-commerce, to movie recommendations like Netflix, to even the YouTube algorithm right here, to social media, etc. And obviously this is a huge area within the big tech space, as big tech has a lot of users, has a lot of content that sometimes user generated, like in the case of YouTube, and sometimes generated by the company itself, like how Netflix gets licensing to host videos. And so ML engineers are the ones working on these algorithms that can show people the content that they want to see. So rec systems are really complicated on the back end because they're dealing with tons of data, but ultimately the whole point of the models is to predict, given a video and a user, will the user end up clicking on this video? Will the user end up watching this video? Or given a video and an item, will the user buy this item? Given a user an ad, would a user click on this ad, or would a user buy the product presented in this ad? I could say a lot more on rec systems. Rec systems themselves deserve a whole video on their own. Let me know if you guys want to see a video on that. So the last bucket I would call Gen AI, or generative AI. This is a new one, and this one arguably I would say uses the least traditional machine learning. You don't even need to be a machine learning engineer, because unless you yourself are working on these giant models, usually what happens is an engineer would use an API provided by the company to use their model. So there's not much actually training involved. There is some prompting, but that is more an art than a science. So let's say you're an airline and you want to have a customer support bot. A few years ago, you would use a cutting-edge pre-trained model and you would fine-tune it on customer support airline data. You would train that specifically as an ML engineer. And then you would deploy that model into production to build your own chatbot. Nowadays, it's just an API around like ChatGPT or Claude or Gemini. So now what do machine learning engineers do at smaller companies? So at smaller companies, all this work would typically be done by MLEs who would have to make use of TensorFlow, PyTorch, or publicly available libraries like that. And these ML engineers would typically have to build their own system from scratch. They'd build the data pipelines themselves, they would use publicly available libraries, open source libraries, and everything would be run themselves. So at mid-sized companies, you might actually still see companies run A/B tests, and at large companies as well. So an A/B test is typically a test where you have a control group of a small set of your users that are going to be using the current system as it is, and you're going to compare it to a test user set where your test users are going to be using your change. So The whole point of running an A/B test is to gather an online metric. So typically, larger companies are going to have a more well-defined online metric they want to improve. For example, if you're an e-commerce website, you're going to want to improve revenue. So if you're making a change to one of your recommendation models for like product recommendations on your e-commerce website, you're going to want to make sure that this change improves revenue. So when you A/B test, your test group, the revenue should be higher. Of course, running A/B tests can be actually very costly and expensive, especially if your model is bad or your change is bad. So what you want to do is you want to have a good proxy or offline metric. This would typically be your typical loss function or accuracy or a UC curve, F1 score. And this metric should be a good proxy for the online, meaning that you don't want to have what's called O2O issues or offline to online inconsistency, meaning you don't want your proxy be good, but then your online metric go down. So startups probably don't even need to worry about A/B testing. They just want you to deploy a change and kind of go off the vibe of if they're getting customers or not, if their customers are happy, because things just move too fast. But at mid and large size companies, they're going to be running A/B tests, with large companies actually having their own A/B testing platform. And so the whole goal of what machine learning engineers do is always make a change, see a good offline metric, hopefully see a good online metric if they have been well defined and what's called calibrated or aligned to the offline metric. Meaning if the offline metric is high, online metric should be high. And then if the online metric is good, then ML engineers would deploy their changes. Big tech has a lot of unique challenges when it comes to machine learning that other companies don't. Their models are huge. The amount of data they process can be terabytes, if not petabytes. And on top of that, they're going to have a lot of machine learning engineers working on a lot of changes at the same time. And topping that all off, it can be very, very costly to the company to accidentally run a bad change, even an A/B test. Especially imagine if you're, for example, YouTube and you're on the YouTube ads team and you're running an A/B test, changing your model for ads. Imagine running a bad change for that, even for a small, tiny subset of users. You'll cost the company hundreds of millions if you're not careful. So there's a lot of considerations to be done. And on top of that, because you have a lot of ML engineers and things are being done at scale, you're not going to want to reinvent the wheel and keep having people build the same training loops or optimizing on the right hardware or all of that. So you're going to need well-defined roles in big tech. I'm going to categorize the different types of ML engineering roles into 3 unofficial buckets. So the first one is called the platform/infra ML engineer. And you could argue that this is the role that is most closest to what a software engineer does, where a software engineer would work on a definitive product change and roll it out into production for a group of users to use, think like a backend system. ML engineers don't want to reinvent the wheel. Actually, in big tech, ML engineers who are working on the other 2 categories that I will talk about, like modeling, for example, don't want to be bogged down in the nitty-gritty of coding. Actually, we don't really deploy that much code at all. Like our changes come in the form of changing config files. Now, these config files have to be processed by a system or a platform. And so these platform ML engineers need to be familiar with all these libraries, for example, PyTorch, Keras, TensorFlow, how to optimize them efficiently, run them on hardware, how to deploy them, how to scale them. They're dealing with all this nitty-gritty stuff. Regular modeling engineers don't want to be dealing with that because we want to be just making improvements to the system. So you're going to have an entire team effectively building their own platform, their own UI for monitoring training. That brings us to the next bucket, and that's what I would call modeling. And that's the work I do currently. So what I would call modeling is just typical ML work. You're going to make either a feature change, a change to the architecture of the model itself. If you're dealing with multitask multi-learning models, that could involve adding a new task. It could be changing the loss function, you name it. And so modeling engineers in big tech usually, like I said, involve changing these config files to implement the change. So in theory, the change is come up with a hypothesis, implement it, see all good offline metric, test online, deploy. But in practice, again, at big tech, it's a little bit more complicated than that. Mainly because even if you have a good change in mind and you're ready to put into production, these companies will have massive productionization process because you're going to be competing with a lot of other ML engineers doing similar changes that you don't want to conflict with your given change because they could cancel each other out. For example, if you add a feature and someone else adds a feature, these features might actually conflict and cancel each other out. I can explain the workflow of modeling engineers in, I guess, about 4 steps. The first thing is you want to understand what your model is doing and what features, architecture, tasks, loss functions it already has in of itself, so you're not reinventing the wheel. The second thing that you want to do is you want to actually get ideas to make the change. How do you get ideas? How do machine learning engineers get ideas? Well, we get them from industry papers, what other engineers are doing in our company, or just broad suggestions from tech lead. It does help to be on top of the field and to have a deep understanding of ML. And then the third thing, once you have ideas, is how do you actually implement it into the model? It sounds so simple. How does it actually work? If it's a feature, do I need to talk with a data team to get this feature? Do I have access to it? If it's a data change, like what upstream tables do I need to find? What data teams do I need to work with? And if it's a modeling change, how do I implement it in the context of my model and where? Once you actually do that, you will train a version of your model and you will observe an offline metric. And then if that works, you will test online, either via yourself or via a special productionization process that your company might have. But the productionization process, again, usually only happens at these large Think-style tech companies. And then if you're lucky, you will deploy your change and observe meaningful movement and metric. And the last bucket I want to talk about when it comes to type of work MLEs do, this usually doesn't involve a model change, but a change to like how the models interact in a given system. Okay, so that was a lot, but hopefully you all now have a better insight into the world of ML engineering, especially ML engineering at big tech. If any of the topics I discussed are of interest to you, please let me know in the comments and I can make a dedicated video on that topic. Otherwise, feel free to let me know what made sense and what I could be clearer about in the comments down below. I'm always open to constructive feedback. And if you like what you heard, then I'd love it if you subscribed or left a like. I plan on making many more of these types of videos in the future. Thank you so much for watching this, and catch you in the next video.